I want us to look at the thing that can go wrong when we are leveling. And one of them is to make sure that the instrument is in perfect adjustment. One enemy of the level in terms of errors is what we call the collimation error, line of collimation error. Okay, and the level is very important when it comes to construction. So the levels, setting out for instance, you want your oversized concrete floor to be level, or you want a drop somewhere, maybe it's a building, maybe from living room to porch, there's a drop of 15 centimeters. You want to make sure it is correct. The level can help you. But if there's something wrong with the level, you can get it wrong. And imagine pouring concrete and realizing that the heights are not correct. It means you have to break. And it has a lot of consequences, financial, reputational wise, and then time. You wouldn't want that. So you want you to make sure before you start using the level is in perfect adjustment. There's no line of collimation error. So we're going to learn how to determine if the level is in perfect adjustment. There's no problem with it. So as I was saying, when you get to site and you are given a level, you should be able to conduct a test on it quickly. A level you are not used before, you are not familiar with. You should conduct a test quickly on it to be sure that it's in perfect adjustment. It's not going to throw you off. It's not going to let you make mistakes which will be costly on site. And that test for the auto level is called the 2-peg test. So how is it done? All you do is you look for a fairly level ground on the site. You peg 2 points at about 100 meters or 50 meters. So let's say we peg this. So we peg one here, we peg one there. The distance between these 2 points being 50 meters. Okay, the distance between these 2 points being 50 meters, and then we look for a center. So this will be 25 meters, 25 meters. So, and then we set the instrument here at the center. Okay, so I'm going to name this A, B, and I'm going to name another point here as C. Okay, now, so what you do is that for a 2-peg test, you set, when you have selected these 2 points, A and B, which actually 50 meters apart, you set the level in the center. That's 25 meters from A. Then you observe, you put the staff here, reading staff here. Then you take the staff reading over here. Okay? You take the staff reading over here. Then come and take the staff reading over here too, without moving the instrument. Okay? Take the staff reading over here. Now you record the staff reading. So the staff reading at B, we'll name it B prime. The staff reading at A, we'll name it A prime. Okay? Now, after taking these readings, we move the instrument to C. Point C. Now, point C can be like 5 meters from A. 5 meters this way from A. Okay? To really test the equipment, 5 meters from A. Then we take a reading. Definitely, it's going to be different because you have changed the instrument station, the height. So, the reading you get here, so we name it, the reading here, A prime prime. Okay? Then the reading at B, we name it B prime prime. Okay? Now, don't forget that the height difference, when you take this reading and you take this reading, the height difference between B and A is going to be B prime minus A prime. Okay. Now when it comes to C, okay, the hybrid string between A and B will still be B prime prime minus A prime prime. Now, if the instrument is in perfect adjustment, there's no correlational error, then this difference, the first difference, that's B prime minus A prime, must be the same as B prime prime minus A prime prime. It should be the same. So it means the difference between these two differences should be 0 or very close to 0, at most 2 millimeters. Error is okay. But if it's more, maybe you are getting something above 1 cm and the rest, then it means the instrument has a problem. You have to take note of it and see how you adjust it when you are doing your observation. So with that, you make sure that to overcome this, if it's not so much, maybe 1 cm, 1.5 cm, you get a difference of that. It means the instrument has some collimation error. To take care of it, make sure that when you are transferring height, you maintain the same distance between your backside and your foresight. That's the same horizontal distance between the backside and the foresight. That's one way to take care of it. Or the other way is to keep very short distance between your backside and your foresight to take care of it. So this is how to test. So let's say if the difference between your two reading, two differences, that's B minus A, B prime minus A prime, and then B prime minus A prime prime. The differences between these two, it's like 5 cm, 4 cm, then you know that you are in for trouble. That instrument will have to go for recalibration. You don't have to use it. It will throw you off and to introduce errors. I want us to go quickly to how to read the staff. How to read the staff. Then you see this. You see a thing like this. Okay? Now, this is a start, okay, of a 10 cm. The start of a 110 cm. So this is 10 cm. This is another 10 cm. This is another 10 centimeters. 10, 10, 10. That's the way it's divided. So a group of E and bars is 10 cm. This is 1 centimeter. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Don't forget that the E, a bar of the E is 1 centimeter. The space is 1 centimeter. Another bar is 1 centimeter. Space is 1 centimeter. Another bar is 1 centimeter. Okay. So if you see something like this here, 1, 0. See 1, 0 here. It means that this line is the start of 1.000 meters. Okay? So this actually 1.000 meters. Now, you will see that you will see 1 here. That's 1.1. So until you get to 1.1, everything here is 1.0. Then the rest follows. So 1.0, the bar, a full bar is for the second decimal place. The third decimal place is an approximation between this. We are going to divide this bar into 10. And that will be for the third decimal place. That's the millimeter decimal place. So if the line passes through here, the horizontal crosshair, the one I drew, this line, horizontal crosshair, it passes through this point like this. Like this. It means that your staff reading is what? 1.0. Now for the second decimal place, 1.0. You have 2 more decimal places to go to get a 3 decimal place. The second decimal place is the bars. Okay, so you are here. How many bars are here? 1, 2, 3, 4, 5, 6, 7. So 7. Then the rest is an approximation between the two, but you realize that it's on it. Let me say it's on it, so it's going to be 0. If I assume that it's a little bit above it, I can make it 1. I can divide this into 10, make it 1. So that's how the reading is. This reading actually is going to be 1, 2. So it's going to be 1.200 meters. That's the reading here. Okay? If it passes here, let's say it passes to the middle here, it's going to be what? 1.1. So 1.1, 1.1. I'm looking for my second decimal place. Now to come. 1, 2, 3, 4. Okay? So 1, 4. The third decimal place, I'll divide this into 10. It's in the middle. So I'll say 5. So 1.145 meters. That's how the staff reading is done. That's how the staff reading is. We do the staff reading. So we'll take note of that. We'll now go to site. We'll demonstrate the 2-peg test. And we'll see what some of the things that the level can be used for on the construction site. Thank you.